are up to 198 members, and we've got some new folks since our last meeting. Gordon Brack, are you here? How about Julio Encarnacion? I'm probably butchering these names. Keith Lee?
Online.
Okay, welcome. Tom Rudge? Todd Sherman? Todd, welcome. Austin Sakauskas? Cadence Hanneman? And Kathy Gentilecore? All right, welcome.
Hey, Dave, which one of these Todd Sherman? I went to high school with Todd Sherman. You're not Todd Sherman. Not the one I went to. Yeah. Well, I saw his name. Said Todd came all the way to 1981. Eastern High School. Okay, 1985.
And do we have any visitors here for the first time? Welcome. Glad to have you. Okay, the last star party out at Chiefland was July 19th, and I believe it was good weather. There's a really cool picture on the left that Matt took. And then there's a beautiful view of the Milky Way. If you haven't been there, it's very dark skies, so it's easy to see the Milky Way. Okay, the next one coming up is this coming Saturday. And as always, try to arrive an hour before sunset. Please register to attend at the website. You register, and then in so doing, then you'll get an email if it's go or no go at noon that day. Weather is iffy right now, maybe, but you never know what'll happen. And that's a shot from inside of the large dome there. And once again, the Milky Way is very prominent. Okay, Matt and his helpers put on a really great ATM last Saturday. And for the new folks, ATM is amateur telescope making, but that encompasses lots of different technical things about telescopes, eyepieces, mounts, and whatnot. And that's, again, Matt got us a really great venue, the same place we had the holiday party last year. And I believe hopefully we'll get it scheduled for again this year. But we had a nice turnout. It started off with a really great presentation by Dr. Hennig about telescope types and eyepiece types, and when it's overkill to buy an eyepiece, you can't, your eye's not even big enough to see it, and different sizes of mirrors showing what great things you can see. Size does matter on telescopes. And then Tom was very helpful. He helped folks with some equipment problems and mirror cleaning. And then there he is with a telescope that he made 50 years ago. So it's still cooking along. And then there's Mike. He built that telescope on the right there, did an amazing job. It's just beautiful. What is that, a 10-inch?
10-inch. A lot less than 50 years ago.
A lot less than 50 years ago. And then how big's the next one you're building?
16.
Oh, that's a big one.
That's big.
16-inch. But as you can see, a lot of us were interested in hearing about the specifics on it. Had a little crowd there. And then he did a little sun watching out there in the parking lot. And then there's Jerry's equipment. He's got a real nice setup, and folks were asking questions about his rig, and he's getting very anxious about getting going on astrophotography. And then Matt brought his equipment. I think that gold Coronado solar scope, I don't know who brought that, but it added to the mix. For the newbies here, there are telescopes that are dedicated just to look at the sun. And more equipment from Matt. And then those pictures are ones that Matt took. So in a very short amount of time, he's gotten really good at astrophotography. And by the way, those are mounted on glass from the back, deposition layers from a company in Alachua, fractured. And it's beautiful what they can do with any kind of photograph on glass. So I'm sure you'll see these pictures again at one of our events in the future. Okay, the next Far Out Journal Club is August 28th, 7 p.m. And the featured guest is James Traley, I think is how you pronounce it. But he He runs a lot of webcasts. He works for NASA, does movies, and there you see Cosmic Dawn there. That's recently released. You can go on YouTube and watch that. It's a really good documentary that he produced about the building of the James Webb Space Telescope. So this guy is really good. Be sure to register at the website for that. You don't want to miss that one. And then the next one after that will be in October with Raider Lane. He's a park ranger. We had him on a Zoom session several years ago. But Rich goes every year to the Star Party at the Grand Canyon, and it's just fantastic out there. And then December 9th, it's going to be called Double Stars Converse. So it'll be our own James Alberry and Dean Regas. And then Terry will officiate on that one, and then we'll have some questions at the end. So we got a really good lineup going. Is that an old picture? But you're with a telescope. I like that picture. Okay, tonight and tomorrow night, the Perseids will be able to view, hopefully, but there's a full moon, so it'll make it tougher. But they'll be out there if it's we don't have any clouds. Okay, Matt is multi-talented. He just set up a astronomy club store, and you can buy T-shirts with our logo, or you can get the logo for the very small array. That's the color logo on the back of that shirt, or a stainless steel travel mug with the logo on it. And as time goes on, I'm sure we'll have more products on there. But if you want to get a picture of that QR code right now, you can, and you can sit right there and order stuff if you want.
There's also a link from our website, that navigation is the link to the shop.
Okay. All right, we just had our board meeting recently at which I appointed Orlando and Jerry as our nominating committee. In November of every year, we have our club elections. So they are the nominating committee. And our bylaws requires that I appoint one more person from the general membership to be on that committee. So I'll just ask, do we have a volunteer who would like to serve on the nomination committee? If I don't get a volunteer, I'll appoint someone. So anyone, it's not hard work. Any volunteers? Okay, I'll do it during the break. Okay, does anyone have any announcements? If not, I'm going to turn it over to Hal McAllister at this time.
Indoctrinate you on the procedure.
Click this on you. You can put it right there. And then there's a little switch up there. It's muted right now.
Okay. Okay,
And
great.
then just to
The
advance,
usual.
the usual, just a down arrow.
Okay,
flip.
great. Okay, good. Well, good evening, everyone. This is I think my third appearance here. Whoops. Yeah, I've already violated the rule. Now you can hear me because I can hear me too. It dawned on me last year, and I've been looking through telescopes since I was 10 years old and most of my life professionally, but I'd never seen Pluto. And I thought, what does it take to see Pluto? And I had just bought a little 400 millimeter ASCAR FRA 400 that is now located in at Starfront Observatory in Texas. And I talked about that during my last short talk. So I thought, and while it was still here in Gainesville, I dragged out my driveway and come up with a scheme for looking at Pluto. Now, Pluto has a special place in my heart. You'll get to see more why as I proceed here. But for a number of years, I was an adjunct scientist at the Lowell Observatory in Flagstaff, Arizona, where Pluto was discovered, and still have good friends there. And the facility that I spoke about a year or so ago, the Char Array, almost ended up in Flagstaff, but for stories best told over beer or something like that, it did not, as it turns out. It's at Mount Wilson. So here's the title. Can you see it okay? And I would like it a little darker because there's going to be a lot of low-level images here being an astronomy talk. So here it is. Can you see Pluto, which is 14th to 15th magnitude, with a small aperture telescope? And the answer, I wouldn't be here talking if the answer were no, right? That would not be that fascinating. But you can't talk about Pluto without first talking about Percival Lowell, because it was Lowell who was really responsible for Pluto's discovery. And you can't talk about Lowell without talking about Mars. So let's talk about Mars for a minute or two. Percival Lowell was born into a Boston Brahmin family, the Lowells, and the Lowells, it was said, spoke only to the Putnams, and the Putnams spoke only to God. So he was a real silver spoon kid who, after he graduated from Harvard with a degree in mathematics, he for a few years did some gentlemanly money making by running a cotton mill before he decided to travel the world. Here he is. Notice his dates. If you do the arithmetic quickly, you see he died when he's only 61, which was a real tragedy. Brilliant man, driven man, ambitious. He had a stroke at an early age and passed away rather quickly. But he became famous early on for opening up the Far East. He wrote best-selling books on Korea and especially Japan that introduced the Western world and the United States to cultures that had been quite foreign to us at the time. This is a picture of Flagstaff, Arizona. How many of you have ever been in Flagstaff? Wonderful place. Well, let's call it Flagpole. I don't know, Arizona, but there's a hotel back there in the middle. You can see the hotel sign sticking up a little turret window called the Weatherford Hotel, and that's still there. They have a little bar and a grill. Flagstaff doesn't look very different today than it did in this picture. This was taken by my mentor in astronomy at Chattanooga, Tennessee, astronomer named Carl Huyer in 1938 when he was traveling in the U.S. And you can see the cowboy there with a cigarette in his mouth standing there on the corner. And if you look closely, if you know about the history of Arizona, you'll see two buildings have the name Babbitt associated with it. And the Babbitt family was prominent in the state, and there was a governor named Babbitt not that many years ago. But Flagstaff is great. Now this, you can see Mars Hill, where the observatory is located, back in the background. It's a kind of a large flat area located over town. And Percival Lowell came there and was courted by the local citizenry to build an observatory. He was the first, truly the first astronomer driven to go to build a telescope where they should be put and not where it was convenient. George Ellery Hale built the Yerkes Observatory close to the University of Chicago in an awful place, Williams Bay, Wisconsin, observationally beautiful place to visit. Realized rather soon that that was a huge mistake, and then he focused on Mount Wilson Observatory after that. Famous picture of Lowell looking through his 24-inch Clark refractor, which when it was built was one of the largest refractors in the world. Still is, of course, a very large refractor. He got interested in Mars early on, primarily because of reports from the Italian astronomer Giovanni Schiaparelli of seeing lines on Mars that Schiaparelli called canali. And Percival Lowell transliterated that into the word canal. And in canali are natural features, and canals are man-made, human-made features. So that just by calling them canals rather than canali, it kind of changed the subject a bit. I like this first line in this Popular Astronomy article from 1894, when he personifies Mars by referring to Mars as him there, which I only noticed that when I was preparing this talk. But he had an early interest in Mars. Here is Schiaparelli's beautiful and totally fictitious map of the surface of Mars. But Lowell became convinced that he could see these through his 24-inch and drew maps, drew hand maps, and wrote books about it. He even took what was purported to be the first photograph of a Martian canal, which is in the image at the left. And you can see some lines in there. And there's still kind of a lot of give and take about where the canals come from. But apparently it's a kind of a trick your eye and brain pull upon you when you're looking at, if you've ever looked at Mars through a telescope, it's a tiny thing. You know, it's far enough away and it's a small enough planet that it's not like looking at Jupiter. But so here are three books that he wrote that were well received and bestsellers, 1895, 1905, and 1908. And you'll notice the first one was called Mars, the Mars and its canals, the second, and then Mars as the abode of life. So there was a huge evolution in his thinking about what was going on Mars during this time frame, and it inspired a lot of wonderful and classic science fiction. I grew up on that book in the middle. In fact, it was a series of 10 books by Edgar Rice Burroughs, who was the creator of Tarzan. And Burroughs populated Mars, as it's called, from Earth, but the Martians call it Barsoom. And John Carter was the hero in it, swashbuckling stuff, just great stuff. Anyway, here's the best and highest resolution map of Mars. There are no Martian canals, period. Okay, so dead end bump steer number 1 from Percival Lowell. Next comes bump steer number 2, and that involves a planet X. And of course, we all know that Neptune was discovered mathematically by deviations in the motion of Uranus from simple Newtonian gravitational motion. And John Couch Adams and UJJ Leverrier sort of independently and simultaneously discovered mathematically that there was an 8th planet, and Neptune resulted. And I don't know, the Brits won out, and Adams usually gets first credit for it. This really touched Lowell, and he began thinking of, well, why can't you find a trans-Neptunian planet? And his first idea was that there was an association with meteor streams, the orbits of meteor showers, with planets. And so he said, well, there's a meteor stream. In fact, I think it may be the Perseid. It's buried in here somewhere, which is associated with something out at about 40 astronomical units. And so this was his first inkling that there might be a trans-Neptunian planet to go after. And of course, he was thinking around something the size of Uranus and Neptune, not something that turned out to be the size of Pluto. Lowell, being a mathematician, thought that he could do for Neptune what Adams and Leverrier did for Uranus, and discover a 9th planet that he called Planet X in the mathematical residuals to the orbital motion of Neptune. And he did this analysis, published it the year before he died, saying that you could reduce the residuals, make them smaller by putting a planet out there somewhere between the mass of the Earth and the mass of Neptune. Well, this turned out to be kind of a classic example of over-interpreting mathematical data, which is, I mean, that's the only way you can regard it. But it inspired him and his astronomers, the Lowell Observatory was well advanced by then, to search for this trans-Neptunian planet X. And Percival's brother, whose name was Abbott Lawrence Lowell, was the president of Harvard. He was an equally illustrious man. In fact, he was the first university administrator to invent the concept of majoring in college. You didn't major before that; you just became a gentleman, traveler of the world with your knowledge of history and so forth, I guess. Finally, the women were allowed to become even better at it than we are. But Lowell was, because he was a Lowell, Abbott Lowell gave money for a telescope devoted to looking for this planet X. And it was this telescope that was used eventually by Clyde Tombaugh to really discover the planet X, the trans-Neptunian planet. Here are 2 pictures of young Tombaugh in 1928 standing by a long focus Newtonian reflector that he made by hand. And you can see he's even got the label there on the side. This is a picture that's also in the collection of photos that I have from my mentor, Carl Huyer, that shows this gentleman with a mustache standing by the rear end of the telescope that Abbott Lawrence Lowell built for the discovery of the search for planet X. And so I wasn't sure, I'd never seen a picture of Clyde Tombaugh in this vintage. And so I sent it to the fellow who was the director of Lowell, and he gave it to their historian. And he said there was a 3-month period during 1938 when Tombaugh grew a mustache. And this is probably the only picture of him with that mustache. But he's got his hand on the plate holder. And so this telescope, the scheme that they developed to look for the planet was to take a photographic plate, big thing that had maybe 100,000 stars on it, tuck it away. A few days later, maybe a week later, take another one, and you blink them. You line them up on an optical device called a blink comparator, which is coming up next. Here it is. This is the actual one that Tombaugh used, and you can see these 2 gigantic photographic plates, and you very carefully scan back and forth after lining them, and you look for a star jumping back and forth from one plate to the other after you have all the other stars co-lined so they don't jump back and forth. And the trouble is, of course, that let me see if I can back up here. Okay, it didn't work, did it? Well, then you saw the picture before. I had a bunch of pictures of the moon across. That was a field of view of these photographic plates. They were enormous, much larger than the field of view that I had with my little camera. And here are the discovery images of Pluto taken by Tombaugh in 1930. And you can see the arrows pointing to little tiny dots on either side. And they were taken 6 days apart in January 1930. The third plate was taken and the weather was very unfavorable. Winter in northern Arizona could be beastly. And Clyde Tombaugh was purported to have spent his afternoons pining away at the local movie theater, watching Tom Mix or something like that. I don't know. But eventually it happened and they announced the discovery of Pluto. It was named Pluto for several reasons, but the one that really struck the observatory best was that as a monument to Percival Lowell, the first 2 letters in the word Pluto are PL. And in fact, the astronomical symbol for Pluto is a blended P and an L. Anyway, this was bomb steer number 2 because Pluto does not have nearly enough mass to perturb Neptune in a discoverable way, even I think with today's observing capabilities. So it's often referred to as an inspired accident. Had Lowell not had this itch, Pluto would not have been found. So good things came of it all. Clyde stayed at the observatory for another decade, completed photographing around the entire ecliptic plane, discovered hundreds of asteroids and all kinds of variable stars and all sorts of other stuff, and made a tremendous contribution to astronomy before he left Lowell and ended up at New Mexico State University in Las Cruces, from which he retired. Okay, so that's my long preamble. So looking for a small telescope. This is my little telescope, which is sitting in building number 8 at Starfront Observatory. And it's an amazing thing to be able to use it as I do. This is a picture of the field of view with the camera that I have showing, and this Pluto is in this. How do I know this? Well, in fact, here's the size of the picture. This is if I had not botched up the image of Clyde Tombaugh's field of view, you'd see a lot more moons across it. But this is still 2 by 3 degrees, bigger than that. So this is a lot of area. And PixInsight tells me that there was something like 28,000 stars in this image. Pluto is somewhere in that little square. How do I know that? Well, we know the orbit of Pluto now. We know, and Tombaugh did not. And you can look it up for any night you want to, and you can go looking for it yourself. But you really can't tell. It's unresolvable. It looks like a star. It twinkles. It doesn't show steady. Has no discernible disk. So you really have to do what Tombaugh did, which is what I ended up doing. I blinked it from 1 to a few days apart and was able to see it through the images. Let folks get comfortable here. So this is a finder chart from the sky. Over, and you can see the 3 epochs here, 13th, 16th, and 19th of July. I actually took pictures on the 10th and the 13th, and this is last year, 2024. This is not from the summer. But you can't go back and bring up old finder charts after the fact on that website. So here is the field of view that I thought I would search in, and Pluto is in here. Do you see it? Okay, let's see if you can see it blink. So I'm going to alternate between one and the other. Now notice that the picture on the right for the 13th of July, you see fainter stars than the one on the left. And I think that's because I set the black level too high, the one on the left. That's my best explanation. So that's the story I'll stick with. I don't think it was a better night. But so here's a picture. Now I'm going to go through this 3 times before I show you where it is. But look at this one and see if you can see some stars disappearing and reappearing. So here's the 10th. Here's the next night, back on the 10th, the next night, back on the 10th, and the next night. Do you see any stars hopping around? You probably do. It really sort of stands out. Now, knowing that they're there, so here's where Pluto was. It's a big dot, much bigger than the dot on the photographic plate. But, you know, this was taken with a modern digital sensor, not a, fraction of a percent quantum efficient photographic emulsion. So, and here it was the other night, and here they are together. You can see them going back and forth. So Pluto was easy to find. But if I had looked at it, even if if I looked at it with a 200-inch telescope, a Palomar, and I would have seen a bunch of stars, you couldn't tell which one was Pluto because it shows no disk. Now, if you compare where Pluto was observed with where it was predicted to be, it turns out there's a problem. And I'm not quite sure what the solution is. But so if you look at this is a blending of where I saw it and where the finder chart said it would be. then I think what the problem was how the finder charts were made. If you look at the picture on the left, that is the cursor readout from PixInsight on the image of Pluto. And if you look at the alpha delta, the right ascension and declination there, and then look at what the sky, where the sky said they were, they agree within the single arc minute and arc second. So I think there was probably an overlay. Maybe they had an equinox problem and going from one to the other. But anyway, I'm sure that was Pluto. It wasn't another planet just following Pluto out there. Now here's a picture of Clyde Tombaugh that I took in 1987. I was visiting New Mexico State. They were interested, the guy who was the chairman of the department there was interested in getting the heck out of Dodge in that job. And so they invited me to come out and back behind my wife, who's standing there in the middle, Susan, are the husband and wife couple, Rita and her BB. Rita still is a very prominent planetary astronomer. And Clyde's wife, Patricia, is standing there at the left. This is in his backyard. And he has the telescope he's leaning against. That may look familiar to you, but he has that big scaffolding that looks like a hangman would take you up there and drop you off with a rope around your neck. But he was still a telescope builder all his life. And here's a real important souvenir to me, a picture of me much younger, as you can tell, with Clyde Tombaugh. So there's him with that telescope. That's the same telescope that was in the picture in 1928 that he built as a kid in his front yard. New Mexico, Las Cruces is pretty dry. You wouldn't put it in the front yard here, it disappeared in a year. There are a number of books about this. My favorite is the first one, which was written by a newspaper man who was a scholar in residence at Lowell during the time I was going out there, Bill Hoyt. And it's a wonderful book, Planets X and Pluto. And then the one in the middle was written by Patrick Moore with Clyde Tombaugh's assistance. And then David Levy has a more recent one. So I'm just going to read this to you. You all know this. At the 206th triennial meeting of the IAU, which has the official responsibility for nomenclature and definitions in astronomy internationally, a proposal had been submitted to demote Pluto from planethood to sort of a sub-inferior planet that ended up becoming known as a dwarf planet. And it was voted on and passed. And I think there are maybe 10 dwarf planets now, and Ceres is actually considered a dwarf planet. Has a surface, it can have weather, has a moon. Those are all ingredients that constitute dwarf planets. There are countless of those out there. So I agree scientifically that Pluto was not a planet in the sense of trans-Neptunian Neptune. But I voted against it, and the colleagues I took from my research center out there with me, we all voted against it. We stood up and said no, so we enjoyed that. But that was a tribute to Clyde Tombaugh, who died in 1997, and a portion of his ashes were put on the New Horizons spacecraft, which visited Pluto in 2015 and is now exploring the Kuiper Belt. And NASA plans to keep supporting the project until it begins to exit the Kuiper Belt. So we hope that happens. And there's that great picture of Clyde looking out between his telescopes. Okay, thanks very much.
Any questions for Hal? Okay, so that back from you.
And it's a nice laptop. Can I take that too?
As always, we have a small token of our appreciation. Hal. No, you're not getting away.
Okay.
We
Like
like
to put me on any committees.
Okay. Yeah, I can give you a €2 coin, commemoration of the birth of Galileo, 450th anniversary of Galileo. It was minted in Italy in 2016. So that's Hal's second one. So if he goes on that eclipse cruise next year, him and his wife will have spending money.
Thank you very much.
Thanks so much.
Thank you.
Right, that was excellent. All right, let's take a 15-minute break right outside the front door. There's refreshments out there. Reminder, don't bring any of the goodies back inside. We'll see you back in 15 minutes. Okay, we might have a few stragglers. I'm going to go ahead. introduce Noah Rashkind, who's a partner at Lott and Fisher PL, where he specializes in intellectual property law, including patents, trademarks, and copyrights. He earned dual undergrad degrees from the University of Florida in astronomy and political science, followed by a JD from Stetson University College of Law. He also holds an MS in astronomy from the University of Florida and is a registered patent attorney admitted to practice before the U.S. Patent and Trademark Office. In addition to his legal practice, he serves as an adjunct professor in the Department of Astronomy at UF, where he teaches the art and science of astrophotography, an interdisciplinary course he developed in collaboration with the Astro Department Chair Liz Lotta, who we know. A lifelong amateur astronomer, he founded ARTstronomy online, a fine art astrophotography business offering curated prints of deep sky, solar, and planetary objects. Noah previously served as an assistant public defender where he gained significant litigation experience. He integrates his background in litigation and scientific training into both his intellectual property practice and his teaching. Based in Gainesville, Florida, Noah balances a rigorous professional life with passions for astrophotography, ultra running, and education. He remains active in public outreach, higher education, and the arts. Please welcome Noah Rashkind.
The next introduction. I am really excited to be here. It frankly is an honor. I sometimes think I have a bit of what is the word? Imposter syndrome. So I am a lawyer by trade, and yes, I have a master's degree in astronomy, but I still think of myself as an amateur. And the way I got into astronomy, well, everyone has their own story, but the way I got into it really started here. And I show this picture to my students every semester, and one or two of them can pick out what it is. I suspect the age of this crowd might be able to get it easily. Yes, this is the cue for Space Mountain as it looked in approximately 1985. And so when I was about 5 or 6 years old, I used to go to Disney World all the time, still go there a lot, but the line at Space Mountain no longer looks like this. But back then, it had pictures of various nebulae. And one of the ones that I took note of at that time and really do remember as a core memory is that first one up on the left. That's the Horsehead Nebula, which was on the first slide before I moved to this one. And throughout my elementary, middle, high school career, I wasn't necessarily very science oriented. I always was very interested in astronomy, but I never really took an active role in sort of furthering that until I got to the University of Florida my freshman year. I had always planned to go to law school. That was what I knew. My father was a lawyer, and I thought, well, it looked like a nice career. I might as well head that in that direction. And I majored in political science. And for those of you who went through the University of Florida, liberal arts degrees require, even if you're majoring in political science, you need to take a certain number of credits of science or physics classes. And so I remember going down the list my first semester and looking for a class that fit that description where there was a letter P after the class. And I came across Discovering the Universe, AST 1002. And even before the first day of class, I'm not sure if you can maybe brighten the room a little bit, but I went to Barnes & Noble. For those of you who are too young to remember, those are where you used to be able to go to buy books. And I think it was the one on Archer Road. And I remember walking through the magazine section, and I saw this magazine. This is the actual magazine I picked up in the fall of 1990. It may have actually been the summer of 1998. Actually, no, this is the September issue. And I held on to this. This was something that was very special to me at the time. It ultimately was something I went through and revisited many, many times. Yeah, the articles were really neat, and I enjoyed reading those. But what I really enjoyed were the pictures of the nebulae. So, and this is what was like state of the art in 1998. This is the best you could do. And in addition to the pictures, I also was captivated by the technology of the time. And for those of you who remember this, these are the Meade line, Meade LX200, LX50 line. And I just thought they were so neat. And I had never seen one in person, and I didn't realize right before classes started that when I took the lab portion of that class, AST 1002L, I think is what it was called, or 1022L, we were able to use Meade telescopes at the campus teaching observatory. So I got my hands on with the Meade telescopes. That company is now out of business, but at the time it was like, if you were an amateur, that's what you wanted to get your hands on. But I wanted to just take a minute and say that I wouldn't be standing here right now if I did not take AST 1002 with Professor Howard Cohen, who is in this room. And so I want to thank them from the bottom. And I mean that seriously. There's a lot of people that change the course of your life. And he's one of them. And I don't know that he necessarily knows that, but he's always held a special place in my heart. So I want to thank him for that. Along the way, along the way, after taking his class, I realized that there was another class I could take as a political science major without actually having to take a math or a physics class as a prerequisite. And so I took a class, I believe it was with Bo Gustafson. It was a planets class. And I enjoyed that one thoroughly. And then I realized that if I wanted to take any more classes, I was going to have to start taking math and physics. And I realized that political science required you to take a number of courses that weren't necessarily with like on that track. You could take a lot of electives. So I ended up filling with all of my electives with math and physics. And I wasn't necessarily that good at those classes. I got through them, but I really was taking them so that I could take the higher level astronomy classes. And I did. And I remember taking my, I think it was my first 2000 level class, my first 3000 level class with Elizabeth Latta, who apparently many of you know. I remember during that class, I enjoyed that one. And at some point during that semester, I believe it was the beginning of my sophomore year, she bumped into me and said she had wanted to know if anyone was interested in maybe working a really boring data reduction job. It's not paid, and again, she emphasized it was boring. And if I could just put the word out that she's looking for somebody to let her know. And I said, well, I'm interested. And she said, well, it's really boring and it's unpaid. And I said, well, I would really like to do this. And so as it turned out, it was really cool and it paid. And it actually was, I was able to take the stipend that I got from working on the Flamingos project. The Flamingos project, if you don't recall, it was a Florida near infrared multi-object it was a Florida multi-object near infrared GRISM observational spectrometer, a mouthful. But it was an instrument that was built at the University of Florida and was used at Kitt Peak National Observatory on the 2.1 meter telescope there, as well as the 4 meter telescope. And I got to go out there and do astrophotography on those telescopes. It was a lot of fun. I did not know, I wasn't the one programming the telescope. I wasn't the one, coming up with the science, but I was able to sit there and focus the telescope. This was back, I guess, before autofocusing. The 2.1 meter telescope didn't have an operator, so I got to operate the 2.1 meter telescope. It was really, really, really neat. The near infrared imager required liquid nitrogen refills every morning and every night. I got to play with that. So it was just a lot of fun. And that stipend ultimately allowed me to purchase my second telescope, which was one of these telescopes that I showed you before, an LX200 10-inch. And so I had my eye on it for a couple of years, was able to purchase it. And so for the first few years of my astronomy career, if you will, or in the amateur world, I did a lot of observational stuff. So I remember my first telescope was an ETX 90. which is a 90mm Maxitov Cassegrain. And I just enjoyed looking at the sky, surveying the sky. It had a controller with it, but it didn't work that well. But I enjoyed allowing my eyes to receive photons that had left objects many, many years before, and they just so happened to fall onto my eyes, and how neat is that? So that was how I sort of started with astronomy, and I didn't get into astrophotography until much later. I will say that I know that there's some new people here, and some of this stuff probably seems very intimidating to the new people, but I'm glad there are new people here. A lot of this stuff it is actually can be quite approachable if you just give it a little bit of time. But what I found over the years is the best telescope, and oftentimes new people say, what's the best telescope to get? The answer really is the one you're going to use. And so I eventually ditched the large 10-inch telescope and shifted to something that wouldn't break my back, shifted to something that if the weather was kind of iffy, I would still go out, because this is something that once it's put together, I can just bring outside. So I've shifted from large telescope down to this is a 71mm refractor, and I've not looked back. So I've switched over to astrophotography almost primarily from observational. So I ultimately came full circle at some point a few years ago. Like I said, Horsehead Nebula was what got me really started. And it wasn't until maybe 5 or 6 years ago that I was able to produce my own version of the Horsehead Nebula. And this is a one-shot color dual narrow band image. If for those of you who work with the one-shot color cameras, I know that for the purists out there, some of you will, I'm probably gonna ruffle some feathers. I actually prefer one-shot color. And the reason for that is the versatility of being able to take an image of the sky with a limited amount of time and be able to get a color image. Not all of us have a permanent observatory or have hours and hours and hours to take multiple images through multiple filters. And I have found that a one-shot color camera in the middle of town, which is where I do most of my observations, not far from Magnolia Park, so to give you a sense. This was taken right next to Magnolia Park, and it might have even been on a night with a full moon. That's how good the technology has come, especially with the narrowband filters. We're also, when I teach my class, we do most of our observations out at Lake Alice. And if you've been out to Lake Alice, you know that it's dark for campus, but it's still pretty bright. It's 4 to 7. But we could get really, really good images with narrowband filters. So, like I said, I'm glad there are new people here. I noticed there were some newcomers. And so my hope, by the way, is that I know that there are people in here who are probably more advanced than I am, and there are people here who are brand new. My hope is that I say something that that each one of you will be able to take home just even a little tidbit of knowledge or information that you hadn't considered. So I know that many of you know what stellarium is, but if you're new to this, stellarium is a really cool planetarium program. It's free, although I think there is an upgrade for some of the features, but highly recommend stellarium. As I said earlier, the best telescope or the best camera is the one you're going to use. And so when I started teaching this astrophotography class at UF, the idea was we wanted to make it really accessible. And so the idea was it would be a cell phone astrophotography class. That's how it started. And it still starts that way, but we've incorporated telescopes like this into the class. But if you are an iPhone user, you know that if you want to take a picture of the sky, although lately it's been getting easier with newer phones, it's really, really hard to get your phone to autofocus on the sky. So what you really need is a program like Nightcap. I recommend if you've never used Nightcap and you're thinking about downloading it, just make sure you focus on that logo, because there's a number of different applications that you can download that are similar in name, but they don't work the same. But this application will allow you to set your focus manually. It will allow you to set your exposure time manually, and will allow you to set your ISO manually, and it makes nighttime photography a cinch. It will also allow you to do star trails. It will allow you to capture the International Space Station, meteors. It's a really neat program, highly recommended. If you are just now getting into astrophotography, you've probably heard of SIRIL. And if you haven't, it's the free version of PixInsight, which I'm sure some of you have heard of but are too afraid to use. I will say that when I started to really get into astrophotography, I used a program called Nebulosity. It didn't really work that great. And I kept coming back to PixInsight as a potential option. For those who already use it, you know the utility of it. But for those of you who are considering it, I have a tutorial at the end of this presentation that sort of walks you through step by step how to create an image. But if you have not tried using PixInsight, I recommend getting the free license for 30 days and trying it out and really focusing on the tutorials that are available on YouTube. When I first downloaded it, I remember I played with it for 30 days and I thought this is the worst program ever. It is not intuitive at all. And even now that I know how to use it, it's still not intuitive. I click the wrong button sometimes. But after the 30 days was up, I still didn't know how to use the program. And this was in the, I don't want to say early days. I'm not really sure what the early days were, but this was back when there really wasn't a lot by way of tutorials online on how to use it. There were a few. And so I sent a message to the PixInsight developers and I said, I know my 30 days are up, but I don't know how to use this program. I promise you, if you give me 30 more days, I'm going to figure it out, and then I will probably buy it. And that's what I did. And I spent probably, I don't know, 12 hours going through videos and doing step-by-step tutorials to figure it out. And I recommend, if you are on the fence about PixInsight, watch those tutorials. You can do step by step, and I have a link to some of those YouTube channels where you can learn. Some of my favorites are Quiv the Lazy Geek. I don't know if anybody has viewed his stuff. He's really good. There's another one, Lukamoto is another one who's very, very good at explaining the steps. At the end of this tutorial, like I said, I created a presentation about 1.5 years, maybe 2 years ago. And my workflow has actually changed a lot since then because the program is constantly being updated. So whenever there is an update, luckily there is somebody who's really, really smart who will make these tutorials and will allow the rest of us to learn from what they have learned. So why do I ultimately do astrophotography? Well, if you can't tell, I really love being up and talking to you all about astronomy. I've always had a passion for it. I will say that the way that I got to, how did I go from law, right? So I was currently intellectual property attorney. Before that, board certified in criminal trial. How did I go to then teaching astrophotography? Well, I'll tell you. So as I started to get and if you haven't noticed, I'm all self-taught on this, right? So I didn't take any formal classes on this, on astrophotography. But I started to post my final images to social media. And Dr. Elizabeth Latta and I have remained friends over the years, and we've remained friends on social media, and we bumped into each other periodically at the grocery store and things like that. And she would periodically tell me she really likes the work that I've been doing. And at some point in 2022, she let me know that there was going to be an astrophotography course offered at UF. And I was so excited because I couldn't wait to audit the class. And I said, can I audit it? And she said, do you want to teach it? I said, sure. And she said, great, you need to create the course. And so ultimately, the course that I teach, I actually created with Elizabeth. And so it's really near and dear to my heart. I love doing it. The students love it. One question someone asked during dinner was, can you audit this astrophotography course? It's called the Art and Science of Astrophotography. The answer is, I think you probably could, but it has 46 seats and always has over 100 people on the wait list. So it may be difficult. At the moment, it's a Quest 2 course. So if you know what that means, it's one of these courses that on a list of required courses. So the students pick that one because they think it's really neat. So it sounded really neat that I have a business as well. Let me tell you how that happened. My family would tell me, and friends would tell me, oh, we love what you're posting on Facebook or on Instagram. You should try selling your stuff. So I said, you know what, I'm going to give it a shot. So I did, and I created a website, and I created an Etsy store, and I called it ARTstronomy, and I'm a trademark attorney. So I registered the trademark for ARTstronomy for art prints. And like some of you, I also use Fracture to do some of my prints. I also use Easy Canvas prints. And I also use Illuminize, which is a business in Georgia. But mostly it's local with Fracture. I think it's the best quality. So this is some of my, I would say, earlier work. Most of this is these are images taken with this telescope here. This, for those of you who are curious, the main telescope here is a William Optics RedCat 71. It's 350 millimeter focal length. And the camera that I used, one-shot color, like I said, I've always used one-shot color. This was the ASI 183 MC Pro, also by ZWO. So early on, as many of you astrophotography veterans will know, none of the gear in the amateur world would play well with the other gear that you own, right? So I had the LX200 that I would stick on a mount, and the hand paddle would get me where I want to go, but the mount wouldn't talk very well to the camera, and I didn't have a guider, and everything was wired with Ethernet cord, and I was outside with a laptop because there was no Wi-Fi, and I'm getting eaten alive by mosquitoes. I thought there had to be a better way, right? So when I ultimately decided I wanted to come back to this and get more into it, I decided that I was going to get something small and portable, like what you see here, and I wanted something that was like all in one, and everything would talk to each other. And if you don't know where I'm going with this, ZWO is like the best thing that has happened to astrophotography probably I don't know, probably ever. It's basically the Apple of astrophotography. If you don't know what ZWO is, it's just an all-in-one system where that is powered by your iPad. You can do it remotely. So I can set this up outside. I can set up my plan. It'll plate solve for you. You can set up plans, and you can be inside watching a movie or sleeping. It's just great. So this is most of these images here, like I said, are with the 183 MC Pro, except for the image of Saturn. That one I took, which I think I have here. So so many of you know what lucky imaging is. For those of you who are relatively new, the way we photograph planets is we generally will take videos of the planet, and as the atmosphere is distorting the image, sometimes it'll distort it into focus, and those are the images that you want to have and stack and combine. Well, this is an image I took. I don't know, is it good? You guys like it? Is it look good? This I took in 2003 with my 10-inch LX200. This was a single image, a 0.2 megapixel camera, and manually focused. So this was like a really lucky image. There's no stacking here. So I think I got really lucky with this one. This is another type of image that you can get with this setup here. This is actually I use the Optolong L Pro to kill the light pollution. And this, by the time I took this image, I had switched from the ASI 183 MC Pro to the 2600 MC Pro. I'm going to get into sort of a discussion about. Oh, okay. So this is, I will say, this is a good example of how you can actually add it. So this setup here is originally, the way I had it is I would use a single filter to capture hydrogen and oxygen to create an HOO image. And so you're not getting the typical Hubble palette, which is sulfur, oxygen, and hydrogen, but you can sort of create that in post-processing. And this was the best I could do with just the hydrogen and the oxygen. When I switched over to the larger camera, I also decided to add a second dual narrowband filter that included sulfur and oxygen. And so it added a level of color that the HOO does not. So if you are a one-shot color camera enthusiast, but you kind of wish you had the ability to get sulfur, there's a way to do that. The ASCAR Color Magic D2, if you already have a dual narrowband HO filter, you can add that, and actually it's a great addition if that's something that you're looking at adding. And this was also with the Optilong L Pro. Here's a good example of how image processing is really, really subjective. So this is the same data. I just processed it the same day, just two different ways. So I like to talk about the art of astrophotography. This is what my class did last semester with the same data set. I would walk them through how to process an image step by step. We all did it step by step, and it's always so fun for them to save their results and then show me what they look like. Because even though we used the same data from the same night, we did follow the same steps, everybody's image came out different. So what I think that's really neat about astrophotography is you can always put your own spin on how you want the art to look. This is also with the L Pro filter. And this adds the sulfur. But going back to what I was saying earlier, the best setup is the one that you're going to use. So you can do astrophotography with a cell phone. This is a cell phone image taken in Bronson. Obviously, there's a comet in the background, but you can do astrophotography with a cell phone. You don't need to buy a large setup like this. So getting back to that, I will say, I would say up until a couple of years ago, if somebody said to me, what kind of telescope should I get? I'm brand new. I would tell them to get a pair of binoculars because you're going to be really frustrated with a small, cheap telescope. But I think if somebody was to ask me today, I would probably tell them the ZWO C-Star. So if you've not used that, it is essentially this packaged into a little box with the same software. But really, I think what I would suggest you do, so a lot of times people say, what's the best setup? And you're going to get a different answer from every astrophotographer you talk to. Oh, you need to use this focal length. Oh, you need to go shorter focal length. You need to get this kind of camera. What I would recommend you do is work backwards. So if you're thinking about getting into astrophotography and you've got advice from me, you've gotten advice from this person over here, this person over here, and you're just still not sure what to do, go to astrobin.com. And that is essentially, if you have never been to that website, it is essentially Instagram for astrophotographers. I'm on there as ARTstronomy Pro. The reason why I'm suggesting that you go there is because if you're thinking about getting into astrophotography, you might stumble onto that site and see the kind of image that you're going to want to replicate, right? Maybe you want to do wide field astrophotography. Maybe you only want to do planetary. Maybe you want to do solar. Maybe you want to just do lunar. Maybe you want to do a mixture of those things. What I would suggest you do is find a series of images that look really neat to you and click on it. And in the post, there will be, what was the camera? What was the telescope? What was the mount? It will give you a really good idea of what you would ultimately want to purchase if you're on the fence about what to do. Astronomy.tools is something that is standard that people recommend. If you're not sure if this telescope goes with this camera because the sampling might be wrong or the pixel scale might be wrong, that's a great tool to use. So I would suggest going to astronomy.tools to use their free calculators. But if you're brand new to this and you're insisting that you want to get into this and you want to buy something, I would recommend go to Astrobin. That is actually one of the reasons I ultimately ended up with the setup that I have. So I'm giving you some advice from things that I learned along the way. Something that I started to use until what you see here, to make flats. So for those of you who are already sort of doing astrophotography and you don't take flats, or you're not really sure how to take flats, or you're using an iPad or a t-shirt method, and you want something simple, I would recommend going to deepskydad.com. Especially if you have a small refractor. I think they actually have flat panels for larger telescopes. I'm not sure how many people work for the company. It's quite small, but they make really neat things. This is a robotic flat panel that sits on the front of the telescope. It acts like a dew shield, not a dew shield, a dust cover rather. And it has an LED you can control either through remote desktop, or there's a manual button that you can press to turn it on, turn it off, and to open and close it. And it makes taking flats just very, 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 very easy. I also recommend you can go to my YouTube, although I don't necessarily have the best tutorials. I do recommend going to YouTube and searching for PixInsight tutorials, or tutorials and reviews of the various telescopes that you're thinking about getting. Something that somebody suggests is great. You might find on the internet, there are people who say that it has all sorts of problems. So I recommend doing research before you purchase anything. Probably most of you have seen this website, lightpollutionmap.info, but this is a great tool to use when people say, where should I go to look at the night sky? You should go to this website and you can pan around, and the heat map essentially shows you where the bright sky is, and the bluer areas are the dimmer skies. And as you can see, the center of that map is Gainesville. So it's really tough unless you're using narrow band filters. It's really tough to do deep sky astrophotography in town, but you can go a little bit out of town, tour in between the cities, in between Gainesville and Bronson. Obviously, there's the Chiefland Astronomy Village as well. But if you're ever wanting to get somewhere really dark, you could just pull up off the side of the road. I don't recommend doing that without making sure you're not going to get hit by a car. But you could pull off the side of the road in some of those areas that are in between towns, and you might be able to get a good view of the sky. So if you're new to this, and if you go to lightpollutionmap.info and you're not sure exactly what you're looking at, you can tap on certain locations and it will give you a lot of information, but it'll give you a border class. And the lower the class, the lower the number, the dimmer it's going to be. For reference, Rosemary Hill Observatory is where that pin is, just outside of Bronson. So it's still pretty bright, even at Rosemary Hill Observatory. You got to go further west to get away from the lights. So when you're getting into astrophotography, you want to really curb your expectations. So if you're expecting to get something like this, you're going to be sorely mistaken. This is because this is a Webb-Space Telescope image. If you're ever curious, how do you know if that's Webb or if that's Hubble? You got to count the spikes. The spikes are 1, 2, 3, 4, 5, 6. That way you know it's a Webb Space Telescope image. If you only have 4 spikes, you know it's a Hubble Space Telescope image. So on the right is a ground-based observatory class telescope, and on the left is what you can get from something like this. So if you crop in, it doesn't look that great. But I'm jumping around here a bit, but I want to just show you. This was as I was saying before. I brought my telescope to class the first semester, and ultimately we got a tech grant to buy 5 more. And it took me 18 hours over 3 nights to put together all 5 of these setups. So that's the basement at the Bryant Space Science Center. But ultimately, this is what you could get with this type of a setup. I think this is a really neat image. It was an accident. I've forgotten to turn on my the mount. But this was an image of the Great Orion Nebula. And what I find is sometimes you make mistakes and they turn out to be pretty and they end up in PowerPoint presentations. If you like memes, this is a great explanation of how the astrophotography process works. And so if you've never used the ZWO ecosystem before, this is essentially what it looks like. And if you were to buy something like this and take your first image and it looks like that, and you get really disappointed because it doesn't look like the image that I showed you before, this is what a raw image looks like, because it includes signal, it includes noise, it includes all sorts of things that you're going to want to remove, including, if you can see just to the left of that pause button, there's this amp glow. It's one of the reasons why I switched from the 183 MC Pro to the 2600, because the 2600 doesn't have amp glow. And that's hard to get rid of without getting really good darks. But you need to not only take images of the sky, but you also need to take calibration frames. And so that's a lecture in and of itself. But if you get into astrophotography, definitely watch tutorials on how to take calibration frames. So this was a raw image, obviously, of a comet from a couple of years ago. There's also an airplane trail. You can always tell if it's an airplane or something else, because usually satellites don't blink like that, but airplane lights do. So that was about a 60-minute interval of that comet that was moving across the sky. And this is a final image that I processed through PixInsight. So you can go from something like this to something like this fairly quickly. Now, one of the things that I show this to my students and I ask them, why does this seem weird to you? And sometimes nobody gets it, but you've got this raw image, and then here's a clip where you can see the comet moving and the stars are not. So does that look weird to you for any reason? Right, it's not trailing. So in this video here, you see the stars aren't moving, right? But over the course of about 60 minutes, the comet moved. So if all I did was calibrate the raw frames and then stack them, either the stars should be trailing or the comet should be smeared out, right? Does that make sense? And the reason it doesn't do that is because, for those of you who know how to use PixInsight or SIRIL, we can actually, during processing, we can remove the stars from the image, process those separately, stack the comet on top of itself, and then combine the two. So you get a combined image that's nice and clean and good contrast and good color, but neither the stars nor the comet is trailing. It's kind of a trick. One of the things that I learned, I go back to cell phones. As you can see, I'm jumping around from big stuff to little stuff. I took this movie a couple of years ago because I knew I was going to be giving a presentation to you all to show you that while you're doing astrophotography with something like this, you can also use your cell phone to do time lapses. This is just a standard iPhone time lapse. And for the new ones, the new folks here, that's the Orion constellation. You can see the Orion Nebula in the sword. And after that, I realized even on cloudy nights, you can get neat images of the sky. You can just barely see the stars poking through. As you can see, we're ramping up in terms of how complicated the videos get. Really, really lucky with this video because later on you'll see the moon goes behind the trees and then there's a reflection on the telescope. But what's really neat about this is that that is the moon. And I'm not shooting the moon, I'm shooting a deep sky giant molecular cloud. And I shouldn't be able to do that, but because I'm using narrowband filters, the moon is totally irrelevant. So long as the moon isn't like right overhead or reflecting too much light directly into the telescope, it does not impact your image quality. And this was the data that I got that night. This is a dual narrowband image. So that is to say that this is taken with a one-shot color camera, so a color camera, through a filter that allows hydrogen and oxygen to pass through. And you'll notice if you're a monochrome camera photographer, you'll notice that it's not as colorful as you might get with a monochrome camera. But as I said, I started adding in dual sulfur and oxygen data, as well as adding in RGB images of the stars. So by the time I do all of that, I might as well be doing monochrome, but it gives me the versatility to not have to do that. But ultimately, I went from this to that just by adding that filter and getting RGB images of the stars. So this is the same data, but adding the sulfur data and using RGB images of the stars. And that was all under a full moon. Here's an example of what you can do with Nightcap, that app that I was telling you about. You can do star trails in your backyard. Here's an example of what that might look like. You can also take pictures of the moon. If you've ever tried to take a picture of the moon with your cell phone and been really, really frustrated, it's because your cell phone is really not good at taking pictures of things that are really dark and then really bright, so at the same time. And so the way to do that is to use a program like Nightcap to control the focus, control the exposure time, and control the ISO. And what's really neat about Nightcap is it has a tutorial when you first open it up, and it'll run you through how everything works. And it also has a link to further materials online. It's really user-friendly. I promise I don't get royalties from pitching that app. But so here's an example of an image. If you're brand new to astronomy, if you try to take an image of the moon, this might be what it would look like on, this was an iPhone 14 or maybe a 12. And then using the app that I just was talking about, you can get something like this. And this is with a cell phone and not through a telescope. All right, so now if we have, do we have 10 more minutes? Okay. Hopefully we can hear the sound. Should we try it?
This is a step-by-step like
Okay.
expanded version of processing the element.
So I'm thinking we should try to maybe switch to the other computer. For people who are considering getting into PixInsight, this would be really helpful to give you a taste of what it looks like.
Okay, so
This is a step-by-step PixInsight tutorial, which is the expanded version of the Processing the Elephant Trunk Nebula video that I made, slowed down with titles explaining exactly what I'm doing, so that you can follow along and perhaps create similar types of results using the techniques that I show in this video. So who is this video for? Well, this is for casual, narrowband, one-shot color users of PixInsight who would like to create an artificial Hubble palette with their images. Who is this not for? This is not for people who are PixInsight experts, people who have only used PixInsight one time or only a couple of times, or for monochrome camera users. Nothing that I'm doing in this video is groundbreaking. I am literally compiling the things that those that I have shown in the credits section have taught me in the literature and in their videos. So step one is to apply a screen transfer function to give you an idea of what your image is looking like. You want to crop your image using dynamic crop. I tend to get rid of stacking artifacts, and if there's any other issues, you want to get rid of those, usually from the corners and from the edges. It's also a good opportunity to center your image the way you're going to want it when it's done. So that's what I've done here. Get rid of that. Step 3 is a background neutralization. I keep everything at default. Go ahead and apply another STF. Step 4 is an automatic background extraction. I usually keep the function degree at 1, and I do subtraction as my correction. Leave everything else at default. Step 5 is an auto color under utilities. You don't have to do this. I've frankly stopped doing this after I made this video when working with one-shot color narrowband data. But it does do a quick color correction, and it's something that you can do. And I only showed it here because I did use it to create my final elephant trunk nebula in the earlier video. Step 6 is easy denoise, which is a good option. I've also begun using Noise Exterminator, which is a paid feature. I actually prefer that now, but I show you this because this is how I created the final version in the earlier video. This does take a bit of time on my machine, 25-30 minutes, so I'm going to go ahead and speed that up just for the sake of getting through this tutorial. Step 7, after easy denoise, is you want to go ahead and stretch the image however you see fit. In this instance, I'm using Bill Blanchin's method, but you can use an easy stretch from the easy processing suite, or you can do it yourself using a histogram function, histogram transformation function. Step 8 is StarNet 2, or you can use Star Exterminator. Step 9 is rename the files if you choose to. Step 10 is an HOO normalization version 3, which is a Bill Blanchin process. Step 11 is a curves transformation. Using RGB-K, create an S-curve. Bring out the highlights and darken the background. Step 12 is increase saturation a bit. This is all to taste. You don't have to do this if you don't want to. Step 13 is to create a yellow mask using Bill Blanchin's process. Once that process has run and it has created the yellow mask, you're going to want to do a mask blur, apply twice, and then apply the mask. And then you can, step 16 is you will hide the mask. Keep it applied, but hide it. Step 17 is you are going to be adjusting the red and the green channels. Increase the red. Should just increase the red portion of the image if the mask was created properly. And then step 18 is you're going to want to adjust the green. In this particular instance, I reduced the green. You'll see other people increase the green in sort of an S-curve manner. It's really to taste. Step 19 is I simply adjusted the saturation up a bit before applying the red and the green curve modifications. Step 20 is remove the yellow mask. You want to remember to do that. And then apply another S-curve to the RGBK just to taste, just so you make it how you want it to look. Give it a little bit of a brighter look. Step 22 is local histogram equalization. This will sort of bring out some of the finer details. Apply a kernel radius of 128 and a contrast limit of 1.2. Usually provides good results, but you can adjust those numbers to your liking. Step 23 is under Utilities, Dark Structure Enhance. Apply that at an amount of about 0.1 to 0.15, which will bring out a bit of the darker features that are currently hidden or muted. It should be very subtle so as to not cook the image too much. Step 24 is add the stars back in. There's obviously multiple ways to do that. Just take your pick. In this particular instance, I used Pixel Math to simply add two files together and create a new image. And then step 25, you can do an SCNR or the modified SCNR to remove the green cast. Now, I had already removed a bit of the green when doing my adjustments, so really the effect you'll see is minimal, with the exception of obviously the stars, which had not had an SCNR prior to removal. And that was it. That was how I created this image. If you have any questions, please let me know, and I'll be happy to make more videos like this in the
So I would say about 20% of that is still part of my workflow. So like I said, as the PixInsight program is updated, I adjust the way I do things. If you are a PixInsight user and you saw that I added the stars in by simply adding the two files together, you probably cringed. That's not how I do it anymore, but there are other ways. And I use photometric color calibration now, and I use blur exterminator. So there's a lot of new tools that have come out even in the last couple of years. And I'm sure over the next couple of years, the tools will change even further. But that's generally how it's done. And just for those who are watching on Zoom, I'm going to include the link to that video in the chat, so not to worry about that. And thank you for having me.
Any questions for Noah?
So I use the Optilong L Ultimate. I started with the L Extreme. I think they're comparable in price. The L Ultimate came out after I started using the L Extreme. The reason I upgraded to the L Ultimate is because it has a narrower bandpass, and it tends to have create smaller star halos. So I use that for the HO, and then I use the ASCAR Color Magic D2 for the sulfur oxygen dual band, narrow band. Yeah. Yes. Good question. This is the ZWO AM5. They've come out with an AM3, which is essentially the same mount, but I think it can carry a lighter payload. Yes, and the brains of this thing is over on this side of the telescope. It's called the ASI Air. It's essentially a Raspberry Pi that has their proprietary software on it that connects to everything. The filter wheel is ZWO, the camera is ZWO, the guider is ZWO, the guide scope is an Orion. The brains is ZWO ASI Air. The telescope itself is William Optics. The autofocuser is ZWO. This power box that I have at the front is made by Pegasus, and the mount is ZWO. I should mention, I a bit of a faux pas, and I should point this out. In the event that you go home and you purchase this, you don't want to make this mistake. This is a very portable setup. It is the tripod is carbon fiber. It's very, very light. What does that mean? It means that this is very top heavy. And so if I was going to actually be using this, the first thing I would do is I would take my battery, which is like 25 pounds, and I would stick it in this little basket here, and that would lower the center of gravity so that the thing doesn't fall over when you're slewing, which apparently has happened to some people.
Is that a harmonic drive?
It is, yeah. So as I was saying throughout the lecture, the best telescope is the one that is the one you're going to use. And I've used German equatorial mounts, and you've got counterweights that you have to use, and they're heavy to bring it in and out. And as I've gotten older, I know I'm not that old, but as I've gotten older, I'm less likely to do the thing if it's going to be a nuisance. And these harmonic drives are just fantastic. I can't say what the other brands are like. You can look at the reviews. There are some people who don't like ZWO. They prefer to use Nina, all open source. The thing is with ZWO is if you buy into their ecosystem, you're kind of stuck, but I'm okay with that because everything works really well and it's very user-friendly.
And I also discovered apparently that just like iOS would use Nightcap, Android would use Nightcam.
Yes. So what I have found, my students have actually found that the native camera on Android is good enough, and you can do manual controls on an Android. But those of us stuck with the iPhone have to add something like Nightcap to give you the manual controls. But if you have an Android, I will probably never own one, although I might want to get one just for astrophotography. The hyperlapse feature on an Android is so neat. It allows you to do star trails, but it creates like a movie that produces the star trails. It's really, really neat. So if you have an Android, you should try using it for that. Yes.
Is it like used here?
There probably is. I'm not the best person to answer that, but I think the club actually has telescopes you can try out. So, yeah, but I think like Astro Mart, maybe one. Cloudy Nights. Yeah, I've never purchased from them. My only experience with that was I had an LX200 that I was telling you about. I've since deforked it, and the computer, the LX200 computer, it was a hot commodity. So I sold that on one of the online markets.
Hey, any other questions? Thanks again. That was wonderful. We'd like to give you one of these mugs. We're between vendors, so we're trying out different mug designs. This doesn't look like anything that I sent you, but it's got your name on it, and it's just a really great mug.
Thank you very much.
You bet.
I appreciate it.
Okay. We will show Howard video next month. And the speaker next month is Dr. Slepian from UF, and he'll talk about dark matter. So, all right, we will see you hopefully at the Chiefland Star Party on Saturday. Thank you.